Hello, welcome to our LVDS educational series with Texas Instruments. My name is Charlie Tsai. In this video, I'll talk about LVDS use cases. First, I'll go over part selection, and then I'll cover commonly used connectors and cables. I'll also cover typical LVDS device applications, and in the end, I'll present a specific use case for LVDS technology. A common question getting asked is how to select LVDS devices. If you have missed previous videos on LVDS overview, you can watch them on training.ti.com. Here, I'll try to provide a few steps to guide the selection process. First question to ask is what standard do you plan to use? LVDS or MLVDS? If you have already knew it, you can jump a few seconds ahead. If not, the next question is what topology will be used. LVDS can be used for both point-to-point and multi-drop applications. However, MLVDS need to be used for multi-point applications. After selecting the standard, device functions and channel numbers should be considered. TI.com offers a simplified product selection process. By visiting the products page, you can quickly filter and select parts based on different criteria. From here, you can start to explore additional features needed. Of course, in the end, volume, target price should also be considered. After part selection, let's look at cable and connectors. LVDS only defines how signals get transferred. It should be independent from cable and connectors. But that's not the case in the real world, because the performance of the cable and connector will affect the performance of LVDS technology. When considering what cable and connectors to use, here are a few things we should keep in mind, such as signaling rate, cable length, flexibility, and cost. Depending on specific application, we also need to make a decision on using unshielded versus shielded, round versus flat, coax versus twisted pair. To provide a few examples, for long transmission lines, a braided or served shield is recommended to ensure good isolation between the signal lines and the environment. The round or flat cable question is usually determined by the environment. For internal board-to-board application with low noise, a flat, untwisted cable is usually adequate, in which case could be ribbon cables. However, in noisy environments, shielding is often required, and industrial standards call for shielded twisted pair, or STP cable. Cat5 or Cat5e is one of the commonly used twisted pair cable that's rated for over 100 MHz frequency. For LVDS applications, twisted pair cable is recommended over coax since it provides two identical conductors to transmit the signal and its complement. Any distortion will affect both conductors equally, therefore the differential signal does not change. Connector selection should follow specific cable type and application need. For example, RJ45 is a common connector to pair with Cat5. FCC, FPC connectors are commonly used with ribbon cables. LVDS is a very versatile standard that supports different cable and connector types. It can transport data, clock, and control signals, which can be used in many applications. Commonly, LVDS devices can be paired with oscillators to transport clock signals. It can be used between DSP board and FPGA to transfer control signals. It can be used to convert single-ended signal to differential and transfer data to backplane. One specific use case demonstrating LVDS devices' capability is the support for SPI bus, which consists of both clock and data signals. It can be challenging to send SPI signals off-board from your microcontroller to a remote board for several reasons. Signal integrity becomes a big concern due to reflections caused by unterminated signal line. It is also less immune to external noises, which may cause communication errors. Electromagnetic interference is also a concern as the high-frequency portion of the SPI signal radiates outward, allowing the signal to couple onto adjacent signals. The advantage of LVDS can be utilized to combat these challenges. LVDS devices such as DS90LV011A and DS90LV012A can take the SPI signals and convert them to low-voltage differential signaling. LVDS works well in SPI applications due to its bandwidth, noise immunity, and EMI reduction. If the application is in noisy environments, a wide common mode receiver, such as SN65 LVDS33, can be used to combat harsh conditions. TI offers a wide range of LVDS driver and receiver that's suitable for different applications. For full portfolio, please go visit ti.com/LVDS. Thank you for watching this video.